So guys, this over here is our LCD and this is the potentiometer. Now let me rotate this knob and see what happens. See, once I rotate the knob, it will start changing the values. I go in this direction, see the values are decreasing, and as soon I keep on rotating, and once I reach the minimum, it becomes nearly minimum. Then I move it in the opposite direction, the values start to increase. Where I leave it, it remains there. So it is displaying this value in percentage. 0 to 100% means it is at the extreme end. Now see, at the maximum rotation, now it cannot rotate further, that shows nearly maximum value. Again in the opposite, it does the same, see. So this seems working perfectly fine. Guys, welcome to learning microcontrollers. In this video, I'm gonna show you how we can interface an LM016 16x2 LCD and a potentiometer with a PIC16F877A microcontroller. Then we will program the PIC in such a way that the value of the potentiometer, whenever we rotate it, will be displayed in percentage form on the LCD. So let's get started. So guys, this over here is a 16x2 LM016 LCD that we are going to use. Now let's do the connections of the LCD first. So this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. This over here is a 16x2 LCD because it can have 16 characters in one row and it has total 2 rows, so it's called 16x2. Then we need a contrast adjustment resistor. This is not the potentiometer we are going to use. This one is only to adjust the contrast of the LCD. We are right now only doing the connections for the LCD. So let's do it. The potentiometer has 3 pins, 1, 2 and 3. The pin number 2, the center one, is the adjustable pin. This is mentioned on the body of the potentiometer. Then for the LCD, we have 16 pins from 1 to 16 if we hold it like this from left to right. Then guys, let's do the connection. Connect pin number 1 and 5 of the LCD like this. Then connect it to the pin number 1 of your potentiometer. Then you send it to the common ground of your PIC like this. In this way, your PIC gets the ground, your LCD gets the ground, and your potentiometer gets the ground from the same source, which is powering up the PIC. Like in my case, I will be using the PIC3. So PIC3 will be enough. It will be able to supply enough current to power all 3 components. So that will be fine. Now pin number 2 of the LCD is the power pin. You connect it to the pin number 3 of your potentiometer. Then you connect it to the VCC of your PIC16F877A. In this way, your PIC gets powered up from PIC3, and then the same power source power ups the potentiometer. The same source also power ups the LCD. So all 3 gets the 5 volt from the same source. Now guys, pin number 3 of your LCD is the adjustable contrast pin connected to the adjustable pin of your potentiometer like this. Now guys, pin number 4 is the RS pin. For this, you may use any available digital input output pin. I'm going to use the pin number D1 like this. For pin number 6, enable pin, I'm going to use the D0 of my PIC. Now 7, 8, 9, 10, you leave them. I will tell you later why. I will directly go for the pin number 14, that is data pin 7 of the LCD. I will connect it to the pin number 30 of my PIC16F877A, that is port D pin 7 like this. Now for the data pin 6 of the LCD, that is pin number 13, I'm going to use a port D pin number 6 of my PIC. For the data pin 3 or 7, 6, 5, data pin 5, I will connect it to the data pin 5. For the data pin 4, I will connect it to the port D pin 4 of my PIC16F877A. Now guys, pin number 15 and 16 of your LCD are for the backlight, and this LCD do have a backlight, so I will connect the pin number 15 to the positive 5 volt and 16 to the ground. So these 2 are to power up the LCD backlight. Now these 4 pins which we left are data pin 0, 1, 2 and 3. These are required in case you are going to use your LCD in the 8-bit mode. I'm going to use my LCD in the 4-bit mode, so I do not need these 4 pins. So just leave them empty. Now this is the connection for the LCD. Now we have this potentiometer over here. You can see that it also have 3 pins. It's just a potentiometer, but the difference is that it is easy to rotate because it have your thumb type knob. So let's do the connection. You can see that it has 3 pins: VCC, adjustable and ground. One is a VCC, then you have the adjustable, then the ground. Now let's do the connections. I will connect the ground pin directly to the ground of my PIC16F877A like this. You can just common it here or there because this all is a common ground. Now the next pin, for the adjustable, you may use any available ADC pin of your PIC. PIC16F877A have like the A port have 1, 2, 3, 4, 5. It have 5 ADC pins. You have total 8 ADC channel. You may use any pin. I'm going to use the pin number A0 of my PIC16F877A for the ADC pin of the potentiometer. For the VCC, just connected to the VCC. So this also gets the power and its input will go to the PIC like this. So now we will program the PIC in such a way that as soon as this knob is rotated, we will get the value of at what value the potentiometer is set on the LCD in the form of percentage. Like from the left to right, it will be 0 to 100%. So in the center, whatever it stops, that percentage will be displayed on the LCD. So simple as that. So before we continue, let me introduce you to the hardware, then we move on to the programming. So guys, this over here is our simple hardware. You can see there we have the PIC16F877A microcontroller. Then we have our 16x2 LCD. There we have the potentiometer, as you can see, this one. This is the potentiometer. It's a 10K. So you may use 10K or whatever you prefer. And to power up the circuit, I'm going to use that PIC3 over there. So this is a very simple setup that we are going to use here. So let's dive into it. Now the next thing what I do is that we will need to get to the MikroC. So let me turn on the MikroC for PIC so we can start programming. So guys, this is our MikroC for PIC. Let me zoom in so you guys can see better. So guys, this is version 7.2.0. You may use the latest versions as well. Just follow my video. It's free to download and use from the official website. So click on File, New Project. This window pops up. Click on Next. Write the name of the project. I write Pot and LM016 interface PIC16F877A tutorial by LM. Okay, learning microcontrollers. So this is the path where your files will be created, and select the microcontroller. I'm going to use a PIC16F877A, and the crystal I have connected to the pin number 13 and 14 is 16 megahertz. I click on Next and Finish. Now here you go, this window pops up. Before you do anything else, first of all save your work. Go to File and click on Save. Here select the path and click on Save. That's all. Now guys, first of all we need to initialize the LCD. Now go to the right in the MikroE libraries expanded. There you have system libraries expanded. Below you have this LCD library, check mark this, expanded. Here you have this LCD I90 command. Double click on it. This window pops up. In the example here you have these commands. You copy them till here. Now you go back, paste it in above the void main loop like this, and here you start defining your pin setting. Now whatever the pins you have selected, you will define here. So you may use any available digital input output pin. Now for the RS pin of the LCD, I have selected pin number D1. For the EN, it's D0. For data pin 7 of the LCD, I selected port D, pin number 7. For data pin 6, it was D6. Then D5 for D5. And then D4. Now this is for the pin out setting. And now do the same for the pin direction, like either it's input or output. Again, RS same, repeat the same as above. For RS, we have D1. For EN, we have D0, then D7 for D7, D6, D5, and D4 like this. Now guys, again go to the right in the LCD-I90 library, double click. There you have this command LCD-I90. You have to copy this command because this command is used to initialize the LCD. Now you place it in the void main loop like this. After that, you may give a one-time initialization delay. I always suggest you give it in the one-time loop. If you don't, even still it will work fine, but I always suggest you do it because in the previous versions of MikroC this used to cause trouble. Now we have the LCD initialized with this pin out. So if you select a different pin out on the hardware, then you just change these commands, that's all. Now guys, we go to our forever loop. I write while 1 like this. Okay, now the first thing, we have a potentiometer. Now to interface a potentiometer, we need the ADC library because potentiometer is connected to the ADC pin. So this is the ADC library. Check mark this, expanded. There you have this command ADC initialize. Double click, and here in the example here you have this command called ADC-I90. Copy it, paste it here like this. Now this command will initialize all the ADC pins of your PIC16F877A microcontroller. Now you may use any ADC pin as you like. Now again go to the right. Now to read data from the ADC pin, that is a potentiometer value, we use this command ADC read. Double click. This example opens up. In the example here you have this command. You copy it, you paste it here. Now in this command you can see that this is the variable which will store the data coming from the ADC pin, and this is the syntax, and this is the channel. Now remember, we have connected the potentiometer to pin number A0. A0 means that channel 0. If it's connected to A1, it will be 1. If it's A2, it will be 2, and so on. So you have to be careful. Now to store the value, we initialize a variable. So I call this variable any name. I call it pot because it will be a potentiometer, and the type I take is float. So you may take the integer, but I will prefer you go pot with floating type because it may have decimal values like this. So in this way, whatever the value is coming from the ADC pin through channel 0 of the PIC will be stored in this variable called pot and the form of floating point. Now the next thing is I also give some initialization delay, not necessary, but I always suggest you give it in the as a safety. So now the next thing is we want the value coming from the potentiometer to be converted to a percentage. Then we will display it on the LCD. Now to convert it to a percentage, I write some comments. What we have to do? We know that formula for percentage is, what is the formula? It is obtained divided by max multiplied by 100. Now in our case, obtained is the value of the pot. Obtained is equal to pot. Okay, one is done. Now the maximum, what is the maximum? Max equals to question mark. Now the max is, I give you the answer. Maximum is basically the maximum resolution of the PIC16F877A's ADC. So PIC16F877A has an ADC of 10 bit. This means it can show a value of 2 power 10. 10 bit means 2 power 10 equals to 1024, which further means values from 0 to 1023, because it's total 1024, but if we also count the 0, it becomes 1023. Now this means that since our potentiometer gets 5 volts, so this means that it can vary an input to the ADC from 0 to 5 volt once we rotate the knob, which will be equal to 0 to 1023 on the ADC side. Now this is our maximum value. This is 1024, the resolution. So this means that max is equal to 1024, and then 100 is 100. Max is 1024, and obtained is equal to pot value, input the ADC value. Now we write the formula. We take another variable for the percentage. I call it float percentage, because whenever there is a division or multiplication going on, always use a float variable. That's a good practice. So I write here percentage is equal to what is our obtained value, that is the value coming from the potentiometer, divided by, and what is our maximum, that is 1024. No variable needed because it's a fixed value. I bring it inside the bracket so we can do the multiplication with 100. Now this is the formula which will convert the value coming from the potentiometer to the which will convert the raw values coming from the potentiometer in the percentage form. After that, I again give some delay. I always prefer you give it. So now here we have our command to get the value from the sensor, then we convert it into the percentage. Now this is the value we want to display on the LCD. Now the problem is that LCD cannot display floats directly. You have to convert this to a string. This LCD can only display strings. Now to do that, go to the right. You have here this library called conversion. You check mark this, expand this. Here you have this command called int2 float. Look for it where it is, this command. Now in the newer versions of the MikroC, you have this command as well, float to string fixed length, and you also have the float to string. This is in the previous version, this is only in the newer versions. So you use this command if you have the latest version. Copy it, paste it here like this. Now float to string fixed length command, this command. Now how to use it? What I do is that you place your float variable which needs to be converted over here like this. Then here is the string which will store the converted value. Now you have to initialize a string. Now in case of MikroC, you cannot directly write like string here. This is not a valid command here, or string here, something like that. This is not valid here. You basically make an array of char. An array of char is also a string. You write char and then you write like I write percentage, and I want it to be an array of 9 because this is more than enough, because we will be displaying like 2 decimal points. It's maximum 0 to 100, or we call it 3 decimal, then so 3 significant numbers, and then after that dot, and then after that it might be like 2 decimal places. So it will be like maximum of 5 to 6 characters. So even if we count all, 8 is more than enough. This will be more than enough to do the job. So an array of char of 9 characters, because we also count the 0, is more than enough. So this array of char is also a string. Now this is the string. We copy this, we paste this here. So whatever is in the percentage will be converted into a string, and in the string form it will be stored in this variable. 6 means that it will be like this. Length, like you have a number called 123.2423. This is the sign also counts. So this is 1, 2, 3, 4, 5, 6. So it will be till here. So in our case we will be having like this. So it will be 1, 2, 3, 4, 5, 6. So this is fine, 6 is fine. Now let's go down. Let me again give some delay here. Now guys, our percentage value is also in the string. Now this is a string, so we can display this on the LCD. Now we write the command for to display this on the LCD. Go to the right. Here you have in the LCD library a command called this command LCD out. Double click on it. This window pops up. Here you have this command. You copy this like this, paste it here like this, and here start writing from the first row, first column, what it should write, whatever is in this per variable, that is our percentage, like this. And after that I want this to be displayed like for, you may set any time, I want it to be displayed like for 300 millisecond, and then it will be overwritten with the next value. And after that I want to clear the screen. Now to clear the screen, these are the cheap LCDs. So you have various techniques. You may use the clear screen command, but that takes a lot of space and time. So I will do a simple thing. I will copy this command again, and I will clear this manually. I know my LCD is 16x2, so maximum character it can have in one row or 16. So I give 16 blank spaces. Start writing from the first row, first column, empty spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Now also do it for the second row as well, because there is always a possibility that once you write on the LCD, then that might leave a sign or something like that. So you have to like clear the screen by any method. So I will use this method. This is a very simple method. Like I will just send an empty line. So they both the rows will get cleared. So this is my code. I built this code. Okay, it's built without error like this. I try again. Okay, let's verify the code before we go for the burning into the microcontroller. So we have the LCD initialized, then we have the ADC pin initialized, then we are inputting the value from the potentiometer, and we are taking port as a sensor, and it is connected to channel 0. That's perfect. Then after that we converted the incoming value to percentage obtained divided by maximum multiplied by 100. That's perfect. Then we converted this percentage value to a string and stored it in this variable. Then we are displaying this variable on the LCD. That's perfect. Build this code again. Now let's open the PIC16 programmer tool to burn it. So guys, this is our PIC16 programmer tool. I also have a lecture on this, how to download and install this tool. If you don't have it, you just go through that lecture. Okay, first of all, you select the microcontroller. I have PIC16F877A. Before I do anything, I will read it to verify that the microcontroller is correctly connected and the PIC kit is correctly working. Okay, that's perfect. For my safety, I will erase it. There must be some code already. I just want to clear that code first. So let's click on erase. Okay, it is erasing device. Please wait. Let it do its job. Okay, it's done. That's perfect. Now it's empty. Now go to the file, import hex file. This is the file we just created. Double click and click on write. Okay, the new file is being written. Just wait. Okay, we wait. Okay, let's go to the hardware until the file is being written. So this is the hardware and this is the file being written. Wait, and this is our potentiometer, as you can see in my hand over here. So we will be focusing on the LCD to see the values coming. So let it write the code. It will power up the circuit using the PIC3. Okay, these are the values we are getting, 65.136. Okay, that is some value we are getting, and that is because the potentiometer is at such a value. So this seems to be right and digit value, and we are getting like 3 decimal places. So this seems fine. Okay, so this is fine. So let me rotate the potentiometer to see does the value changes or not. So this is a pot. I rotate it. Okay, let me bring this wire from somewhere else. Okay, I rotate. Oh, see, the values are changing. So the knob is working fine. See, I go to the extreme end, so it's like near to 0, because this potentiometer is not very accurate. Okay, I move it, so the values change. I rotate it further, values change further, and it goes to the maximum like this. Okay, let me move this. You can have the view of both. Okay. Okay, now you can see the LCD plus the potentiometer. Okay, that's fine. Okay, I rotate it in the opposite. See, the value is dropping. So it is working. I stop it at some space and it remains there. That's perfect. Okay, the LCD is a bit blank. That is because of the camera I am using is not of very good quality. Second problem is the LCD contrast. So we may adjust the contrast, because you have to adjust the contrast whenever you change the power source. So I just rotate this knob to set the contrast, whatever is preferred. Okay, now it is getting more dull. Okay, this is getting dull. Okay, we see whatever is better. Okay. Okay, this is fine. This is better. Okay, now this is better. We can see it even better. So that is all because of camera and contrast, because my camera is not very good. So I think you can see it better now. Okay, let's play with this further. Okay, let's see. Okay, I wish you can see this. Okay, you can see the both. That will be great. Okay. Okay, now let me rotate the knob. See, I rotate the knob in the right side, the values are changing, and where I leave it, it remains there. Now it's at maximum, so it is nearly maximum. Then I go in the opposite direction, it does the same. And once I leave it, where I leave it, it remains there. See, if I leave it in the center, it will remain there. See, so it is working perfectly fine, guys. So this is how you do it. Now this thing have tons of applications. You may use this to control the speed. You may use this to control the speed of a DC motor, or you may use this to control the brightness of an LED or something. I will make videos on these topics as well. So guys, I hope you guys learned something from this video. Thank you very much for your time. We'll see you in the next lecture. So goodbye until then.